Okay, so before I show you how to find out the limit of sine of x over x as x approaches 0, let me just give you a quick reminder on inequalities. And if you don't understand this, I've done a whole section on this. Let me give you a quick reminder. Now, suppose you're given that something, let's say a blue whale plus two sweets, is greater than an elephant plus four sweets. Now, when you've been given an inequality like this, or like this here, let's just say x plus 2 is greater than whatever plus 4. Now, when you've been given an inequality like this, you can actually add equally to both sides, and nothing will change. So, for example, you could add a sweet on this side and on this side here, and this side collectively, this side will be greater than this side. So you could add two sweets on this side here and two sweets over on this side here, and this side will always the balance will not tilt. This side here will be greater than this side. My point is that, well, even if you add a giraffe over this side, okay, and then add an identical giraffe over here, because you're adding the same amount, this side here will always be greater than this side. What I'm trying to say is that, suppose you're given some inequality here, you're told that this here is bigger than this. Well, if you add the same amounts, let's say if you add 3 to both sides, add 3 to both sides, this side you add 3 as well, then you can say collectively, well, single number merged with a single number. So you can say x plus 5 is greater than y plus 7. My point is that when you've been given an inequality, if you add an equal amount, then uh, then then it doesn't really change. This side will always be greater than this side if you add an equal amount. Okay, so if I add, I don't know, let's say 3 sweets on this side and 3 sweets on this side, because I'm adding the same amount, this side will always be greater than this side. Okay, and the same is true with division as well. You can divide equally to both sides, and this side will always be greater than this side. So here, suppose you're given this here. This side is, you're told that this side is heavier than on this side. You could divide equally to both sides. You could okay, let's divide everything by 2. So cut the blue wire in half and only keep half of it, and then cut this in half, and then cut the elephant in half, and cut this in half. What I'm trying to say is half of a blue whale here and one sweet will still be heavier than half of an elephant and 2 sweets. You see, this side will always be heavier than this side. If my point is that when you're told that something is heavier than this than something else, you can, if you add an equal amount, it will still be heavier. This side will still be heavier. If you divide by an equal amount, it will still be heavier. The same is true with multiplication as well. If you times this side by 2, or times by 3, then let's say 3 blue whales and uh, and and 6 sweets here, well, times this side by 3, so you have 3 elephants and 3 lots of this. Let's say 1, 2, 3, 4, and then 1, 2, 3, 4. My point is that this side here will be heavier than all this here. So when you're given an inequality here, if you add an equal amount, divide an equal amount, times an equal amount, take away an equal amount, this will always be greater than this one. So here, if you're told that this is greater than this, if you divide equally, times equally, add equally, take away equally, then this side will always be greater than this side here. And the only thing that you should be well aware of is, suppose you're told that this is greater than this. You can also take the reciprocal equally to both sides as well. But the thing is, you have to switch this sign around. So, for example, you're told that this here is greater than this here. So you can take the reciprocal both sides. So the reciprocal of this side is this. The reciprocal of this side is this. But the only thing is, whenever you take the reciprocal, this sign switches around. So so you're told that is greater than this. So if you take the reciprocal of both sides, it will become this and this. But in order for it to make sense, you've got to change the sign around. So for example, this one here, 3 over 4 is in fact greater than a half, because if you look at this here, 3, 1, 2, 3, it is bigger than half. Okay, it is bigger than half here. So at the moment that this here is bigger than this. Now if you take the reciprocal of both sides, this will be 2, well 2 over 1 or just 2, 2, and then take the reciprocal of this, 4 over 3. But then in order for this to make sense, you got to switch this around. Okay, so my point is that when you're given an inequality here, well, the sign stays the same. The sign, when you're given, when you're told this is the same as this, this is greater than this. If you add, take away, divide, or times, then the sign stays the same. So, for example, if you add 1 sweet to both sides, then this will become this. Y will become this here. Yeah, this side will always be greater than this side. If you add equally, take away equally, times equally, but then if you take the reciprocal of both sides, then you have to change the sign. Okay, I've done a whole section on this before, so if you don't understand this, watch the section on inequalities. But this is just a reminder. Okay.